Um, hello, everybody. My name is Borko Novakovic, and I'm a program manager on SQL Server engineering team. One interesting fact: my team is located in Belgrade, Serbia. We have quite a few engineers there working on SQL Server 2016 and Azure SQL Database, and bringing their international experience to these great products. Today, my goal is actually to help you take a closer look at a set of selected features that are coming in SQL Server 2016. As you probably know, we started our SQL Server journey with you guys on Monday with the foundation session, where we actually had an overview, explained the release at the high level, explained what are the most important features for you, and also continue with a set of sessions with the drill down session. So today my goal is actually to talk about these selected three features. And in short, you can think of Temporal and JSON as being a language extensions, something that you can use to improve your programming model against SQL Server. Features that will give you more in terms of new insights, right? While the query store is really a flight data recorder for your database, the tool that you will be using for performance analysis and troubleshooting. Before we continue, I would like to ask you how many of you were present on the session on Tuesday morning, 9 a.m., where Lindsay and I gave a deep dive overview of SQL Server. So not that many. The agenda for this session is simple as I put in the title. I will start with Temporal and then talk about the query store and finish the presentation with the JSON. I'll be giving some demos. I'll be also taking questions along the way, but we need to keep eye on the clock because the session is packed. So I will stay here after the session and take all of your questions. So don't worry about that. Before we start discussion, why would people use Temporal feature in SQL Server VNX? Let's just first briefly explain what Temporal is. Temporal data is data that is strictly attached to a time dimension, to a time context, right? And you can think of Temporal as an extension of fact table concept from data warehousing, where every row in a table actually is believed to be true only within a period of time that is specified in that row, right? And the same applies to Temporal in SQL Server VNext. And when we talk about the temporal databases, we usually refer to databases that are actually able to provide you with insight about how data has changed over time, very efficiently and simply, right? And it is quite understandable why people would like to use Temporal, because vast majority of the data sources that we know are actually temporal in their very nature. Because data sources changes, and many businesses today require insights that could be actually that one can get from the data evolution. But traditional databases fail to provide insights when it comes to temporal data. And people are actually, they must work on their workarounds. And those workarounds are usually suffer from many different drawbacks. Like they are usually very complex, inefficient, difficult to extend, and many other drawbacks are there. So SQL Server VNext, or SQL Server 2016, is actually there to help everyone who needs to efficiently handle time-varying data. This is really a generally useful feature, something that you can use in a wide set of scenarios and applications. I wanted here to just emphasize the most important ones. By far, the most frequent requirement about temporal is actually time travel. Let me explain what time travel actually means here. With time travel, we assume capability to reconstruct the state of the data universe as it was at any point in time. And also, it assumes that you can compare multiple periods of interest side by side and derive conclusion based on the difference. You can imagine business report, important business report that is generated today, and you usually want to compare that business report with its state as it was 6 months ago. This is very useful insight, right? And temporal database greatly simplify the process of getting such report. Data audit is also one area where temporal greatly help, because for data audit you usually need to keep history of changes for a longer period of time, side by side with the current state of the data, and you need to efficiently and quickly report about the states that data went through within a period of interest. Temporal helps here because it is designed in a way that stores all changes in a very efficient way. Some developer tasks, common developer tasks, will be simplified, like slowly changing dimensions. If you implement slowly changing dimensions in data warehousing using the temporal, you will probably get rid of the complex ETL and data integration logic, because you will let SQL Server to take care about all the details. And finally, temporal is very convenient for DBAs and data quality officers who are concerned about data quality, because it can be used to revert the state of the record very precisely without using backups, without doing backup restores and other operations that are taking database offline. Now, how one can start using temporal? In a nutshell, it's yet another type of the table in SQL Server. So temporal is actually type of the table, which means you will either create new objects as temporal tables, or you want to convert your existing tables to become temporal tables. And we provide a proper support for both paths for you, right? Which means especially important is alter table path, which allows you not only to convert your non-temporal tables into temporal ones, but also it allows you to migrate your existing solution. Yeah, probably many of you have some custom solution built in the application layer. We allow you to easily migrate the data to a built-in support. And the most important thing is that kind of a migration does not imply data movement because it's the only metadata operation. Once you create temporal tables or alter existing tables to become temporal, you will be using them pretty much as you are using the regular tables. This effectively means that all data modifications and select of the current data will be completely unchanged, which is very, very convenient. That means if you have an existing schema, existing third-party application running in your database, and you decide to convert a couple of tables to temporal tables, your existing application do not need to change. They will be just running, and that will be a kind of a very smooth migrations to temporal. But temporal also provides you with additional analytics capabilities. Now you have current data, but you have also history data. And through the T-SQL enhancements, we call them temporal predicates, you are now able to get insights out of history data. And also you are able to combine the current and the history data in order to understand trends and data evolution. I will talk more about all of these in the following slides. But the most important thing you should note here is temporal does not require any change in your programming model, and it also adds new capabilities to your analytics. How this feature works? In a nutshell, temporal is actually a system of two tables. It is designed that way. And we actually refer to them as the main primary table, which stores the current data, and the history table, which is there to collect all history changes. The most important thing your scripts, your applications will be interacting only with the temporal, with the main table. History table is visible for you, but actually you don't need to reference it at any point. When you're inserting the data into the temporal table, only the current table is affected. And in that case, system is responsible for generating timestamps based on the local clock, and the data that gets into the table has appropriate temporal context. If your application is updating the record, then what happens automatically is that previous version of the record goes into the history table without your explicit action, right? And this is the way how temporal history is being built. That happens both on update and the delete operation. When it comes to querying the data, when you're querying using the regular select, when you're querying the current state of the data, you actually reference only the current table. Everything works as you would expect, right? But when you are using temporal predicates, what happens is that SQL Server, again behind the scenes, combines two data sets and provides you with a consistent result. This is how querying looks like, how getting insight looks like on an example. So in this case, we have two tables which make temporal system. On the top, we have the current table, and below is the history table. You can see actually that temporal table always requires two date time columns, which determine the period of validity for every record. For the current table, actually, the upper boundary is not unlimited in practice. We are using the maximum value for the daytime period, right? And this is how actually it looks like from the point of view of SQL Server that is processing your requests. It actually treats those two tables as a unified data set that happens completely transparently for you. And on the right-hand side, you have a nice visualization of the multiple versions that every record has. Please note that for every department ID that you have in the temporal table, there must not be overlaps in temporal sense. That actually means that SQL Server keeps the consistency, temporal consistency of the data for you. Every time when you update the data or delete the data, SQL Server keeps track about the timestamps, and it will be consistent. Now, when you're querying the data, get actual row versions actually will access only the current data. SQL Server is smart enough to completely eliminate the history table from this operation. This is why when you're querying the current state of the data, you won't experience any significant, performance regression or degradation. But now, what kind of insight you can get from the temporal? The first one is getting the snapshot of the table, which means give me the state of my table as it was January the 1st, 2006. And during that operation, I show the records that will be affected. SQL Server is searching for records which period of validity contains point in time that you provided across both tables. And that happens completely transparently for you. Another operation, another type of search that you might want over the temporal table is with the between and end predicate. In that case, you are providing a period. You are actually providing 2 points in time. It is actually period. What you want to get with this kind of a search, it is pretty wide type of search. Actually, this is a search of when you want to get all versions that were active, at least for a portion of period that you provided. Like in this query, I'm searching for records that were valid at least for a portion of period in 2006, right? How that is accomplished, how that is implemented, actually SQL Server behind the scenes calculates or searches for records that overlap with the period that you provided. There is also another type of search that works with period. That's contained in. It is more restrictive because in that case you are searching for records which lifetime is strictly bound to a period that you provided. That means that those records were open or active during that period, but they actually were also closed before period ends. So it's a very specific type of search. Again, works with the period, but as you can see from this diagram, it is pretty restrictive. Implementation of Temporal is, I must say, ANSI compliant because Temporal became part of the SQL ANSI standard in 2011. But our implementation actually goes far beyond the ANSI compliance because what we want to achieve with Temporal is to give you more flexibility and better solutions. One example is how Temporal can be actually configured as a very cost-effective solution. And that is something that really other competitors cannot match. So what is the common problem with temporal tables, regardless of the platform that you are using? After some time, changes accumulate, right? And this is a very strange situation. Your main table is fairly small. But if you had lots of updates during a long period of time, your history table will grow and become much, much bigger than the current one, right? And since people using Temporal for the auditing purposes, very often from 3 to 7 years, in some cases even 10 years, it is very difficult to manage such a huge history table. Of course, they can do partitioning, they can do deleting or truncating partition after some time, but the point is they need to query that data even very rarely. From time to time, they need to query that data. And how basically we can come up with a cost-effective solution? The answer is in a great collaboration that exists between Temporal and other features in SQL Server. In this case, it's a stretch table. Imagine that we configure history table as a stretch table with a predicate based on automatically assigned period of time in a history table, which says, hey, I want to age to Azure everything that is older than 6 months. If I configure a system this way, actually, it will be auto-adjusted in sense that all changes will go to older than 6 months will go to Azure, and you'll have very cost-effective solution in terms that your hot and warm data that you very frequently query are local. On fast disk, you get the great response, but your cold data, which is majority of your data, is in Azure, right? And again, this is not offline solution because in some rare cases, you might want to query even the cold data, right? In this case, I'm asking for the business answer that goes 5 or 5 years in the past. And in that case, thanks to Temporal and thanks to smart query processing that exists in stretch table, we're actually rewriting your query in a way that all data becomes available in an online fashion, which is really a great feature and unparalleled, I would say. Now I will switch to the demo. Yes? Yes. Yes, I can comment on that. That is really good question. So the question was, what is the performance impact of introducing Temporal? So we are thinking about performance impact from two perspectives. One is we want to compare Temporal with alternative solutions. Let's say that your use case is, yes, I need to keep the history data, and I must keep history around, and I must query the data across different periods. In that case, people use either application-built logic or triggers today. This is very common. So we've done some performance measurements, and the solution that we have is on average 30 to 40% better than any other custom solution that you can build. So definitely Temporal is better. Now, when it comes to comparing Temporal with non-temporal case, you can ask the question, okay, I have a regular table. I want to convert that table to Temporal. What is the additional price that I need to pay? When it comes to insert, price is completely zero. When it comes to querying the current data, price is zero. We've done some performance measurement. There are not final ones, but I can share the like preliminary results. So performance overhead is at the range of 30%, 35%, which is probably not that critical if Temporal is really needed in your case. And that performance overhead applies to update and delete operations. Yes.
In comparing to using change tracking and change data capture.
Okay. What?
Yeah. So how are they similar at this?
Okay. The question was comparison between the Temporal and change data capture, right? So those are the different technologies, right? So for the most part, change data capture is used as a data feed for the data warehousing solution. The main scenario is I have a source system and I have a data warehousing solution or other system that needs to be synchronized with the primary one. And I'm using change data capture to get the quick information, what has changed last day or last week or last month, whatsoever. But with Temporal, you can keep the history of data for 10 years, which is really different thing. So basically, scenarios are different. While the synchronization between multiple systems are probably the primary one for the change data capture, with Temporal, it's more getting the temporal insights or keeping the data for auditing purposes. I mean, theoretically, you could use Temporal to derive change data capture-like conclusions, but this is not the main scenario here. I mean, yeah. In this implementation, this is a good question. The question was, can we use the system time only, or we can provide the business data? I guess your question was, is the time controlled exclusively by the database platform, or is the time something that you can control, or your application? With this version of Temporal, we do support only system time. Only system time. It is important that history data and history table is read-only in this configuration. We do guarantee that it's read-only. There are ways for you, there are ways for a user with the permissions to change the history data, but that's not the main case. We want to guarantee that history that we built is actually the real state of the data that existed at the time.
One question. In terms of the indexes that you have on the main table versus history table, they have to be identical?
They don't have to be identical, because those two tables are independent in terms that you can manage them independently. Furthermore, you can choose a different storage type for these tables. For instance, you can combine the row store and column store tables. Imagine probably if you need to keep data for a longer time, you need a solid compression on the history table. Column store would be a great choice for that, because it will offer a good compression ratio, and also the queries that goes over the history tend to be more analytics queries, tend to calculate trends, aggregates, and stuff, while the queries on the current table are more all TP probably queries. But the comment on indexes, yes, you can create the similar indexes, but if your querying is over the history specific, you're free to create additional indexes on the history to optimize for that scenario. There is a configuration with the Temporal where we are creating default history table. If you do not provide any parameter during the creation of table, we will create one for you. In that case, we will create a cluster index on that table which consists of the primary key from the original table and will include both period columns. That kind of an index is optimized for temporal searches for a particular ID, for range searches for a particular ID. Was there more question? Yes? Question was, can we stretch the data anywhere else than Azure? Today, I mean, the first version is Azure only, but as far as I know, this is not my area. My colleague Joe Young is actually owner of that. As far as I know, nothing from the technical point of view prevents us to have replicas, not replicas, but to stretch the table on other destinations. Yes?
Any restrictions on the structural changes you're able to make to a table if you are using Temporal?
This is a good question. Any constraints in terms of changing the schema? While the system versioning is established, which means that those two tables, history and current one, are linked, you cannot change the schema directly. But there is a path for changing the schema. We do allow you to decouple history and current table, change them independently, and then again couple. During the recoupling those two tables, we are performing schema consistency check as well as data consistency check. While the schema consistency check is mandatory, you can skip data consistency check if you want. Let me go to the demo because we need to cover other topics, and then I will take more questions later. So the first example is how you can easily build in the temporal capabilities in your application. This is the simple example of application that I wrote for this purpose, and this actually runs on SQL Server 2016, and it's using temporal. It shows the typical organizational chart, and say that I'm a manager which is included in the planning process. I would like to see the organizational chart, and I would like also to understand how my organization will change over time, right? So it would be really beautiful if this application could allow me to travel back in time. So this is the magical button. I can go and visit any point in time very easily, even go to the period when my company was established and see how organization chart looked like. Not only that, I can compare, or I can see what are the changes that happened in last year in my organizational structure very easily. Now, application is beautiful, and I can say that like coding this application was very easy and fun, and I will show you why. Because the temporal feature really simplifies the process. I will go and show you how this works. This view is an essence of data access layer for this application. This view actually joins three tables: locations, departments, and there is a relational table which says actually which are departments belong to any location, right? And nothing specific. This view is as any other that you create with a non-temporal feature. But let me show you what this view can actually. If I query this view in a regular way, it will just return all records. Actually, it returns the state of the data as it is now. But this view is able to work with the temporal clause. And here you see, with applying a simple predicate on this view, actually actually converts this view into a time machine, if you wish. How that's possible? How this works? What I need to do in order to have this magic for this view? Nothing specific. I just need to create my tables as temporal tables, right? And this is the syntax I wanted to introduce. A couple of comments. Temporal table must have primary key. That is the one constraint. And also here you see two important elements of temporal definition. One is the period, which includes 2 columns. They must be datetime 2. That allows you the best precision that you get. And also a reference to history table. History table can exist before you create the temporal table, which is very good if you have migration type of scenarios, but it will be created if it doesn't exist. We will create a default one for you. It's really flexible. So when you create temporal tables, this view actually behaves as a time machine because SQL Server is smart enough to push down temporal predicates to every table that exists in that view. But also you can combine temporal and non-temporal tables, and SQL Server again will be smart enough to apply temporal predicates only to temporal tables. That's the beauty of thing. Now, when you have this view, you can write a simple store procedure that actually allows you to travel back and forth in time. That store procedure accepts a parameter, and then if it's null, if it's not provided, then that is a current query. Otherwise, it's a temporal querying. Please note that with the temporal querying, you are not restricted to literals. You can write dynamic conditions. You can like calculate as of parameter based on a complex expression, and then push it down to the temporal execution. Yes?
Can you see the to from version date time when you're history table?
Sorry, can
Can you see the version's time, like when in the history?
Yes. Actually, the query that I show here in this view, in this particular example, I don't have it, but if I query like select star from department and for like this is you are not restricted to views. I will make one comment. You can directly query the table with as of predicates. But what is the interesting thing? We have here 3 tables, and all of them are temporal. They are changing independently. Imagine what kind of a logic you would need to write in order to correlate three independent changes. What is the great thing here? You're define a view, and you let SQL Server to take care about traveling through time. This is the most powerful thing. Like you can isolate all your data access layer logic into one view, and then just going back and forth, applying as of predicate, you can travel through time. Okay, that is the example that I had on temporal regarding the development experience. I had in mind to show one example which is related to data audit, which I showed a couple of days ago. I think I'll get back to that example if we have time. Now I'll switch to the next topic, to the query store, because we are a little bit over time. And then at the end of the session, we can answer other questions. How many of you today was in Brent's other presentation? Not that many. It was a great presentation. How many of you had problems, performance problems with SQL Server, and how many of you had to fix them urgently? Okay, this is better. So you know what I'm talking about. It is very bad for you and for us when query performance is not good. And basically, there are many different situations when you can experience performance problem. The most critical one is when the entire application is down because of underlying database being unresponsive. And also, it can appear as a set of intermittent performance degradation that just come and go, and you cannot figure out what happened, and you cannot root cause what is the problem and how to prevent it from happening in the future. And finally, some customers reported that even when they are migrated to the latest version of SQL Server, they experience serious performance issue, which is not a great situation both for them and for us. We do know that Query Optimizer can cause these problems. This is a known thing, right? And why is that? Because optimizing query is a huge problem. It's a very, very complex problem. And Query Optimizer is a great piece of software which is doing its job very well for the most of the time. In some cases, in some edge cases, it can happen that produced plan is not the optimal one. When that happens, with the current version of the SQL Server, you are in a not good position, I would say, because the tools and the infrastructure that is built around the plan cache is not ideal for performance analysis and troubleshooting. As a result, what will happen usually, it will take too much time for you to detect the problem, to even guess what happened, and then to fix or to mitigate the problem. Usually it takes hours, in some extreme situation, even days for you to fix the problem. And this is where Query Store comes into play to solve that situation. And basically, how Query Store helps. What is the infrastructure that is building? Basically, it collects every query and every generated plan ever generated and executed in a system permanently and persistently. And also, it collects all runtime statistics for all executed queries and plans for your review and for your inspection. And not only that, it allows you to pick the best plan from the history for a particular query and force SQL Server to use that one with one line of code or one click in the UI that we provided. So it dramatically reduces the problem of performance analysis and troubleshooting. What you were doing for hours or days, now you can do in a couple of minutes. And that is the main value prop of the Query Store. With this great piece of technology, you can actually do many different tasks related to query optimization. You can quickly pinpoint and fix the urgent query, one that is critical at this point, one that is your application suffering from at this very moment. But you can also do some more longer-term and strategic optimization. First of all, you can use Query Store to classify your workload, to understand what are the expensive queries versus cheap or non-important queries, and then focus all of your energy to optimize only the important ones. One of the areas where Query Store will greatly help both you and us is in the upgrade process. You can use Query Store to fully de-risk upgrade process, to make it safe and smooth in terms of performance. But not only upgrade, other maintenance operation can benefit from the Query Store as well. And finally, having this great data repository in place, you'll be able to get deep insight about your workload. You will be able to learn about recurring patterns, and you'll be able to optimize not only at the level of a single query, but also able to optimize across different queries, across multiple queries, or across multiple applications. So this is the data that is collected by the Query Store. And for the beginning, it's very important to say that there's no query text does not necessarily mean the query. Single query text can produce multiple queries in a system. That's something that you probably know, because under different plan affecting settings, the same query text can result with a different data, right? And that's the reason why query text and unique combination of context settings that you used will produce a different query entity in the Query Store. That's one point. And also, a query in the Query Store is bound to a containing object. What does it mean? It means the same query used from a store procedure, trigger, and ad hoc will be 3 queries in the Query Store. What that allows you? That allows you to independently analyze the impact of every occurrence of that query, and allows you to actually optimize each of them independently, which is a great flexibility. You will have usually multiple plans generated for every query in the query store. Every time when plan gets compiled, it will be stored in the query store internal structures. And then we go from the compile time to runtime structures. Query store divides collected data into time windows. That means it doesn't take every single execution of the query and records what actually happened. It rather aggregates for every plan that was executing in a time window. It aggregates what was happening for that plan, and then those aggregated metrics are stored. This is a balance between the information that you have and the data that you store, right? Because in a huge environment, storing every execution of query wouldn't be practical. I mean, it will just take too much data. But the most important thing, you can control the period. You can control, and by controlling the period, you'll control the granularity of the data that you have in a system. All these structures that I mentioned here are internal tables in the SQL Server, but they are also exposed as a set of new views that are part of the query store. They are part of the sys schema, and you will easily find them by searching using the query store prefix. All of them have query store prefix. The only exception is query context settings. All other are there. But as you will see shortly, you can, of course, query these views from your scripts or from your applications, but there is a great UI that is coming with SQL Server 2016, which actually provides a great insight into the data that query store collects. Yes? Yeah, we could call. Yeah. No. Not in that sense. They do not have prefix DM. Like, strictly speaking, they are not DMVs. So we rather reference them as a kind of a catalog views for the query store. But the important thing, the state of these views is changing over time, right? Because new plans are coming and execution. Every execution changes the state of these views. This is how query store is incorporated in the entire query processing pipeline and what actually happens on every query execution. So probably each of you is familiar with this, and you know how query store process queries. And basically, every time when the new query gets compiled or when new plan gets compiled, it's being sent to query store. There is an interface between the query processor and the query store, which guarantees that data ends up in the query store. And also, when query execution is finished, statistics are being sent to the query store, which aggregates and stores them based on a time window that you specified. This is how query store works if you are only collecting the data and you don't have any kind of a plan forcing that I mentioned. But I mentioned that you are able to pick the plan from the query store and say, I want this plan to be used. And how that works? That works the following way. Basically, in the processing pipeline, there is a check for the recompile. In that stage, query processor is communicating with the query store asking, hey, is there any plan for this query? If there's such a plan, then basically recompile is forced, plan is being retrieved from the query store, and you can think of the mechanism as the plan hint is being applied internally, but the most important thing, that operation does not require any change from your application. It's completely transparent. You can force the plan, and your application will continue running, which was not the case because plan forcing in some other options would require query change. Troubleshooting process for you with the query store should be pretty simple. Query store is a database feature, which means you should first enable it. There is a syntax for enabling the query store. Once you enable query store, you should let it collect data for some time to establish the performance baseline. And then you can start analyzing the data. You can search, is there any query that has regressed, I don't know, in last day or in last couple of days, or what are the most expensive queries in my system that require my immediate attention. And for the queries where you identify their plan choice change was a root cause for performance degradation, you are now able to force the policy. This is one scenario. And another scenario which is also important for us is, as I mentioned already, keeping performance stability during the upgrade. So Brent mentioned that today, and there is an infrastructure that we built starting from 2014, and now we continue with that trend in 2016. We do tie query optimizer changes to a compatibility level, which means, effectively, you can upgrade to the latest version of SQL Server, but leave the oldest previous version of the compat level, and you won't be exposed to the query optimizer, which means you can use new features, but effectively your query execution machine will be the previous one. You are the safe. And if you want to move to the latest version, latest compatibility level, which is expected action because you believe that latest query optimizer will improve many or majority of your queries, then a kind of a suggestion so far and advice was, hey, do it over the weekend when the system is not that loaded, when there are no critical queries and critical processing, and then everything goes smooth, then continue over the working days. If something is wrong, then, okay, move back to the previous compat level. This is a somewhat good story, but not the great one. With the query store, you can really, really improve this experience, because now, with the query store, you don't need to wait for a couple of days to make sure that everything is okay. You now have a tool in place. You have exact data in place to determine, is there any query in the system that has regressed? If it is, you can do something else. You will stay with the latest compatibility level, but you enforce the previous plan using the query store. And this is exactly what I want to show now in the next demo with the query store. I'll be demoing I will try to simulate the upgrade process with the query store, and we'll also will cover some details about the configuring query store. Is there any question at this point before I go to demo? Yes? So far, what we have measured is actually a few percent. It's really negligible. So, and we will make sure that before we ship this product, it will stay in this, within these boundaries. So that practically means, and this is our really goal for the RTM, you should always have query store on in your database, because you don't care about the performance overhead. Yes? Other questions? Yes? Yes, yes, it keeps. The question was, if you disable query store on the database, does it keep plans? Yes, it keeps plans. It's completely separated. As you will see, there are a couple of options you can use to control the size of the query store. And
I'm sorry, I was more meaning when you set the plan, when you force the plan,
okay.
Query will keep that after query store has been disabled?
No. So I will talk more about the modes in which query store can operate, and very shortly. Now, okay. This is the scenario. So I already upgraded my SQL Server instance to the SQL Server 2016, and I have critical database which is ReportDB. It generates reports for the management. In order to make sure that everything is okay, I kept this database at the previous compatibility level, 2012, which effectively means I can use all features, but the query optimizer is actually one that I was using previously. So that means I'm safe in terms nothing can go wrong at this point. And I want to use query store to measure the performance baseline. I will be running system for some time at the previous compat level and use query store to establish the performance baseline. Now let's go into a couple of options that are available with the query store. This is the new, like in the database properties, there is a new tab page, which is query store, and you can use it to enable, disable, or change the mode for the query store. I will go quickly through available options. As I said, query store is by default off. This is not a definite decision. We might decide to go with the default on before we RTM. We would like to hear, of course, your feedback on that once you have a chance to try it out. Now about the modes. By default, query store operates in a read-write mode. What does it mean? It means it collects the data, and all forcing policies are active. All force plan that you choose to be forced will be active. You can switch query store to the read-only mode. That means no more data collection, but forcing policy are still valid. Usually, this is not the mode that you'll be using, but I must tell one thing. Query store is storing the data inside your user database, and you can control how much of the data it will take. And you should set this value very carefully based on your workload. If query store goes over the limit, it will automatically switch to the read-only mode. That means no more collecting, but no more stats and query collecting. You'll miss something, definitely. But all forcing policies are still active. There are some tricks that you can use. Of course, when query store goes into the read-only mode, what you can do, you can go and increase the size, or you can purge the data that you don't need, and then you can again turn it on, right? Not turn it on, but switch to the read-write mode. But there are some tricks you can do in order to prevent this from happening, because it can be a problem. You turn query store on and you forget about the database, and a couple of days after you realize that query store is in a read-only mode. This is not a good situation. So what you can do, you can actually use size-based cleanup mode. If you set this value to auto, what will happen? There is an internal mechanism that will track the size of the query store. When it reaches 90% of the maximum, it will start removing the oldest queries and plans from the system. And its goal to always keep the size of the query store between 80 and 90%. That way you are completely safe. It removes the oldest queries, the one that are the least relevant, and keeps the query store always running. There is also, the last value here is the size-based policy. You can specify for how long you want to keep your queries and execution stats within a system. By default, it's 1 year. You can specify whatever you want. And here is the interval that I mentioned, interval of aggregation. I choose 1 minute for this demo because I'm running workloads for a couple of minutes. But of course, in your case, when you have long-running workloads, you will probably choose 1 hour, maybe 1 day, something that really applies to a workload. Let me now enable the query store, because this is the part of the scenario. Before I move the compat level to the latest value, I want to run my workload, and I want to have query store on in order to establish the performance baseline. By the way, everything that you specify here is scripted, right? So this is the new syntax that we enable for the programmatic management of the query store. And also, there is a view, somehow, yes, this always happens when I'm doing this demo, because I explain what is the read-only mode, and then I leave it in the read-only mode, always. This new view, this is not the view that you use to collect the query store data, but this is the management view. You'll get the state of the query store and its parameter. It's now in the read-write mode, which means it's running. Now I have a simple app that simulates my important workload, and I'll be running that for some time. You can see that this application is running with 110 compatibility level, and it runs, executes some workload that is important for me. Now, where is the place to take a look at the collected data? This is a new folder beneath the database node, which actually has 4 really awesome UIs for the query store. They are provide different kind of a visualization. I'll today focus on top resource consuming queries, and I will configure it to show data only for the last 15 minutes. It's configured for 1 day in order to have granularity. Now, what does visualization show me? It has 3 panes. It actually, on the top level, you have queries sorted by criterion that you provided. In this case, it's duration, which means show me the top 25 queries based on duration. And for the most users, it's really the intuitive metrics, right? But you can use different ones. You can specify by CPU time, or by the memory consumption, or by the I/O metrics, or the number of execution. It's really flexible. When you place mouse over the query, you'll get the query text and some aggregated stats. For the selected query, you are able to see execution, plans that were used. In this particular case, seems that query that is basically top resource consuming query. This is the most important query. It actually is being executed with a single plan. Here we are using internal identifiers like query ID and plan ID. Those IDs are used by query store to distinguish between multiple queries and plans. You will get familiar with these values, because if you start writing your own queries, you will start referencing queries based on these identifiers. And at the bottom, you have well-known the plan UI, right? So basically, if you have multiple plans, clicking on a plan, you'll be able to see what is the shape of the plan. And also, as you can see, there are some statistics for the plan. Every circle actually represents the plan within a time window, right? Now, I established the performance baseline. This critical query runs for 32 seconds. And I actually know what I should expect when I move the compat level to the latest version. Because, as I said, I'll take optimistic assumption. The latest SQL Server is there to help me improve my queries, not to regress existing queries. And I will take that optimistic. I will put optimistic hat, and I will go and change the compat level. I'm brave, and OK. SQL Server says OK. Then I'll rerun my workload, which practically means I'm now at the latest compat level. Users are using the system, and let me see what will happen in this case. Oh no, I know what happened. This is something that I shouldn't show now, because when you're preparing the presentation, you are going through example, and actually I show you the magic. What you should see now is, we'll see that shortly. Sorry, I will leave this guy to execute stuff for quite some time, and you will see what will happen. So this was the previous execution. I was at the compat level 110, right? And let me rerun again. I had the plan forced, yes.
What happens if I go and deploy another version of the store bot? Do I get? Are you able to have the same?
The question was, what we'll get if we change the version of the store proc? Okay, index doesn't affect anything. If you change the version of the store proc, you will get a new object ID. Currently, we do connect query. Every query in a store procedure actually is a separate entry in a query store. So that is important. And there is a reference from the query to the containing object. If you currently, it's object ID. What we will do before we ship this product is we will have also object name and the schema name, so that you can always correlate the query with the store procedure. Okay. What now happens? This guy is executing obviously slower. That is something that I wouldn't expect as a user, but I would expect as a presenter, because this is a fake situation that I made here to show you the value prop. It's executing slower. It was 32 seconds. Now we have more than 70 seconds. What does it mean? It actually means if I go here, I will notice that query store all of a sudden decided to take a different plan. It's smart enough now to try to optimize more, but actually that plan is really worse. I can go and see that average duration is now, let me see how, it's really 20 times worse. It's really something that you can experience. And then, oh, sorry, I will close this guy. 78 seconds compared to 32 seconds. And the point is actually what you would expect. I, as a DBA now, instead of going back to the previous compat level, I can say, okay, I have only one regressed queries. Everything else is fine. Or I have 5 critical queries that have regressed. Let me fix their execution. And this is the button, force button in the UI. And this is now, there is a check mark which says this plan is forced. Now, if I continue running, you can see that actually it's better now, because SQL Server now decided, as you can see, to use the plan that I forced. The point is, you now have full control, and it is safe for you to move to the latest compat level, because Query Store will give you exactly queries that have regressed. And as we also expect, for the most part, you'll get the better performance. You'll be able to notice the better performance with the Query Store as well. So that's actually what I plan to show for the Query Store. Now, let's go and cover the JSON. And any questions so far for the Query Store? It's awesome, yes. Thank you, guys. Thank you. I want to just briefly explain the investment that we are making in this space as well. This is another language improvement that we are doing. And it's really clear why we want to introduce JSON support. JSON became omnipresent, especially among modern web application and web services. And what we really want to do with this investment is to make our platform, database platform, capable to exchange the data with these modern applications of today, right? And not only that, we also want to enable our users to store non-relational data side by side with the relational data, and to combine them in their analysis, and to get this kind of a unified insight across relational and non-relational. Now, the most important scenario, as I mentioned, is with this JSON support in this version of SQL Server is definitely data exchange. Imagine that you have banking application which interacts with a credit risk rating service, and this credit risk service is actually speaking JSON. It speaks JSON, actually. It accepts a request in a JSON format and emits results in a JSON format. Now, what you could do, you could write your own application that will be man in the middle between the SQL Server and this external service, which is really not the business that you would like to be in. You would like to have an easy way to extract your relational data into the JSON format and vice versa. And this is exactly what we are doing in SQL Server 2016. For JSON, who of you have ever used the for XML and OpenXML? Okay, majority of you guys. So this is pretty much similar, even more flexible in this case, as you will see. So for JSON, does the same job. You can specify auto, you can specify path, and you can control the schema of the JSON. Everything is under your control. And also you have a OpenJSON function which accepts the JSON and generates the table as a result. How many of you hates SP prepare document or something, store procedure? You know, when you are working with OpenXML, you first need to invoke the SP prepare XML, and then when you have prepared handle, then you can use it in. This is really inflexible, and it's limiting, right? With the JSON, you don't have this limitation. You just provide the JSON as a parameter, and everything works, which adds also additional flexibility. But not only that you can interact with external web services and applications, but you can also store JSON in your database. And this is what we actually support. JSON in SQL Server 2016 is a plain text. It really simplifies its integration with the rest of the SQL Server ecosystem. It simplifies the loading process and everything. But also there is a isJSON constraint, built-in constraint that we do provide for you in order to control the validity of that document, which means you cannot, if you use the isJSON constraint, your users won't be able to store any text in that field. Also, if you need to optimize further for a specific path, you'll be able to actually create a computed column from the JSON using the JSON value function, and then you can create additional index if you have paths within a JSON that is most critical for you. Of course, you can say now, why don't you guys implement something like selective XML indexes for the JSON? By the way, how many of you are using selective XML indexes? Oh, this is a great feature. You should use it. So basically, it allows you to optimize for a certain path, the most critical paths in your application. So if you are not using selective XML, then you'll be completely fine with this support of JSON, and that's okay. Really, this is a good scenario when you actually have usually you have a couple of paths that are most critical for you. You can create additional computed column, persist it, and create index and optimize for search over that path. How you are querying the JSON? There is a JSON value function that we will provide, and that function works with a path that you specify, and it returns the scalar value from that path. It's very simple. And you can use it in a select statement, or you can use it as we saw in computed column specifications. One thing that is related to querying the JSON. OpenJSON, as I mentioned, it's very useful when you get the result from external service, and then you want that JSON to actually convert into the relational format, and probably you will store it in a relational form, or you might want to join it with your relational object. That's all fine. But OpenJSON is very convenient when you have JSON column in your table, because it works. It can be used in cross-apply statements, which means I have a table with a column, JSON column, and I can provide the column reference to the OpenJSON function for every JSON, for every row from the outer table. OpenJSON will create a resulting table, and final result of this query will be union all of these JSON, open JSON that were executed for each row. Actually, cross-supply works using the table value function interface. OpenJSON actually works as a regular TVF. And in this cross-supply configuration, it allows you to iterate over your table with the JSON column and to produce result. Of course, result table that you generate this way, you can store, or you can additionally join with relational tables in your system. It's really flexible. Okay. This thing behaves strange. Okay. You might be a little bit confused because now we have multiple products working with JSON. We have SQL Server, which works with JSON, but we also have Azure Document DB. Now you might be asking questions, oh, what I should use? What is the product for me? The only common thing for these two products is actually JSON, but the scenarios are very different. So with JSON support, SQL Server still stays premium relational database, which is now capable to exchange the data with modern application and services, and which is allow you to combine relational and non-relational and to get appropriate insight. But basically, it's still a platform when you'll be running your mission-critical application that require schema, right? On the other hand, if you have rapidly changing application that cannot rely on any specific schema, when your data is organized as a set of schema-free documents, then you need something like document store, and on top of that, you'll get scalable transactional processing if you have Azure, if you want to use Azure Document DB. So basically, the nature of the data is very different. With the JSON in SQL Server, you are just extending the platform to non-relational field, while with the Document DB, you are actually using completely non-relational data and non-relational structures. But the beautiful thing is now, since both platforms understand JSON, they can exchange the documents in both directions. And this is how you can use in your advantage to improve the interoperability between your on-prem and cloud platforms. I will just conclude, and then we have more questions. Key takeaways for this session, because it was really mixed session about 3 different features. Quickly, if you have a requirement to analyze data over time, if you have requirements for time-based analysis or for data audit, use Temporal. Use Query Store for performance troubleshooting and tuning in your workloads, and use JSON if you need to extend your platform to interact with modern application and services. The most important thing is all these features are available and will be available, actually, both in cloud and on-prem. So this is the most important thing. Okay, this is everything that I wanted to. Thank you.